Here the standard entropies for X2, Y2 and XY3 are given. And for this particular chemical reaction, even delta H value is also given. And what we need to do here is, we need to find out the temperature under which this particular reaction is at equilibrium. So even though the term delta G is not given here, you need to recollect a very important and basic point that at equilibrium, delta G is always equal to 0, isn't it? So our equation delta G equal to del H minus T delta S. In this one, as delta G is equal to 0, now we have the relation delta H is equal to T delta S. What is delta H? That is clearly given as minus 30. And this temperature at which this reaction is at equilibrium, that is what we are calculating. And what is delta S? And this delta S is not given, that we need to calculate from the given standard entropies of these three substances. So for this particular reaction, how we will calculate the change in entropy? It is nothing but the total entropy of the final, means the products minus the entropy of the initial state, that is the reactants. So entropy of the products means it is entropy of XY3, that is nothing but equal to 50, minus of the total entropy of the reactants, it is half of X2, means half of 60, that is 30, plus 3 by 2 of Y2, that is 3 by 2 of 40, and that is 60. As this value is equal to 90, 50 minus 90 is equal to minus 40 joules Kelvin inverse mole inverse. But here, as delta H is already given in kilojoules, definitely this is to be converted into kilojoules. So this is minus 40 into 10 power minus 3 kilojoules Kelvin inverse mole inverse. So bring this value and substitute here, minus 40 into 10 power minus 3. So now temperature is equal to 30 upon 40 into 10 power minus 3. And now solving this, we get the value as equal to 750 Kelvin. So our answer is option D.